Good morning. I am going to go through section 6.2 with you guys today. So what we're going to do is cover just the first couple problems talking about corresponding parts of triangles, just like we've done in class. I'll do one proof, couple problems, and it'll be pretty short. So just follow along in your textbook. I have no idea what page this is on, I'm not going to lie, but it is in section 6.2. So pause the video, get to 6.2 and you'll find this. So the first thing I'm going to do is talk about what corresponding parts of congruent triangles being congruent in a triangle means. We use this abbreviation CPCTC because it's an insanely shorter way of saying this whole part that's bolded right here. What it basically means is that if I have two triangles that are congruent, I'm going to call this one A, this one B, and this one C, and I'll be really original and call this one D, E, and F. So if I tell you right away that triangle ABC is congruent to triangle DEF, what corresponding parts means, again, we can take our letters, our first two letters of each triangle, and say that those parts are corresponding to each other, which in this case, the ones that I highlighted, segment AB is congruent to segment DE. Now, again, this is kind of backwards from what we did before. So if you think about it, before we started with identifying these congruent statements like I have in red, and then we would get the big one for the triangles. Now we're going to do a proof where we're going to prove the triangles are congruent, and then we're going to use this bottom congruent statement to prove that these corresponding parts are indeed congruent. So it's kind of backwards of what we did with all the proofs before. So let's give one a try. So create a proof, we'll do statement and reason. So with this one, there's actually two different ways that we can do this proof. I'm only going to do one of them so I don't torture you. Let's write down our givens. So first of all, I have that CW, the segment, and segment SD bisect each other, which bisect means they cut each other in half. And that's a given. So the first thing I'm actually going to do right away with that is label my diagram for what that actually means. If CW, which is this segment right here, and SD, if they bisect each other, that means that this part and this part are equal to each other. And it also means that this part and this part are also equal to each other. So that's what bisect is going to mean. I'll write my other given. Actually, we don't even have another given. That's it. So I'm going to apply this first given right now, and that's going to be my second statement here. And what I'm going to do is take my little 1 marks here. So I have segment CP is congruent to segment PW. So I'm going to say CP is congruent to PW. And this is the definition of bisect. Again, bisect, the part bi means it cuts it into two parts. Bisect means there are two equal parts. So CP and PW are one of those parts. Your other equal part would be SP, or PS is congruent to, and I'll use PD. So that's the part going across here. So now I have two sides. Again, this is definition of bisect. So now we have two sides of each triangle so far. So in order to make this proof, I need one more piece of information. I can use the fact that angles S and D are right angles, which means that these are right triangles, and then we could use the HL theorem, but that sounds like a lot of work, and I'd rather do less writing, which I think would be if we decide that these angles in the middle are congruent because they are vertical angles. Okay, so the ones that I made green marks by, these are congruent, and we have the intersecting lines here, which create two angles across from each other that are congruent. They're equal in measure. So I'm going to say that angle CPS is congruent to angle DPW, and that is vertical angles. And now that I have a side, an angle, and a side, and over here I have a side, an angle, and a side, I can make the conclusion that my two triangles are congruent to each other. So I'm going to say triangle, which one is this? CPS is congruent. So if I say CPS, I'm going from the 1 tick mark to the 2. I would have to say WPD. And let's take a look at the theorem real quick. Again, we have a side and then an angle and then a side. So it's going to be SAS, congruence theorem. And then again, at the very end, now that we have this congruence statement, let's take a look at our letters here. I have CS, my first and third letters. This is what we're trying to prove, is that CS is congruent to WD, and it also ends up being the first and the third letters. So what that means is that we can write this down. At the very end, I'm going to say that segment CS is congruent to segment WD, which means that this is congruent to this. And the reason I know that is because CPCTC, congruent parts of congruent triangles are congruent. Okay, so again, I'm going to kind of recap this. Try to follow along with this explanation as best as you can. The first thing that we did is we took the piece of information from the given that we had these segments that bisected each other. So I had a side and then another side from each. What I did in green was prove that the angle between the triangles, these were vertical angles that were created from the intersecting lines, which let us prove statement number 5 here, that we could use side angle side congruence. So once we have this congruence, we can then make the assumption that, hey, you know what? These triangles are congruent, which means all of your angles have corresponding angles and all of your sides have corresponding sides that are congruent. So at the very end, we're allowed to say what I have in blue right here where the cursor is, which is that segment CS is congruent to segment DW. And then, so that's the only proof I wanted to do. And then just really briefly talk about these other two theorems that it makes possible. So what CPCTC does is it makes two theorems possible for us to prove. If you remember back to an isosceles triangle is the triangle where you had two sides of a triangle that were equal and the angles across from those sides were also equal in measure. So having CPCTC makes it possible for us to prove that base angle theorem, which says that if two sides of a triangle are congruent, so suppose that this were true, where I had two little marks right here. Well, what we could do is write a proof now, because I can divide this up into two triangles, and we can prove that angle B is congruent to angle D. So again, I'm going to kind of repeat what that means. It means that if I'm giving you that side GB right here is congruent to side GD. So in other words, if I give you that two sides of your triangle are congruent, that means that the angles that are across from them, what we call base angles, so B and D, those are also equal. What a converse theorem states then is that it's going to basically take your statement and reason and it's going to flip-flop them. So I'm actually going to underline this stuff so it does make sense to you guys. In the first one, we said if two sides of a triangle are congruent, then the angles opposite them are congruent, where now with the converse, we're saying if the two angles are congruent, then the opposite sides are congruent. So what this bottom one is indicating is, let's suppose that angle D and angle B are equal in measure. What it means is that we could prove now that the sides that are across from them are also equal. So it's taking exactly what I just set up here and it's flipping it. So if I were to give you the angles first, you could then prove that the sides were equal. And we are going to apply that in like two problems. But I just kind of wanted you to take a note of this. The book goes through the two proofs of them with you. I am not going to bore you with that. Next one. So an application of this thing, where we're able to see that I have two congruent triangles within this pretty picture. It says, how wide is the horse's pasture, which is talking about this length right here. I'm going to call this X. So if I have my right angle right here, 90 degrees, looks like I have 20 feet for one of my sides, and my other leg of my right triangle is going to be this width. If I look at the triangle that's on the bottom here, you have 20 feet going down for one of the legs, and your other leg is 45 feet. So we're making the assumption in this problem that they are giving me two congruent triangles. So what we're going to do then is use CPCTC, that's a really ugly P, and I can make an assumption then based off of that. I'm just going to put some letters here. I'm going to call this segment AB, and I'm going to call this segment over here CD. And corresponding parts of congruent triangles being congruent, the CPCTC allows me to say that segment AB is congruent to segment DC, which means that segment DC, which I called X over here, would be 45 feet. So again, basically, to recap the fact that I didn't really do much math there, all we did is identify that I had two congruent triangles and that the parts of each triangle line up to other parts. That's what CPCTC stands for. It stands for the fact that if you draw one triangle that's congruent to another triangle, all of your angles will correspond to another angle on the other triangle, and all of your sides on one triangle will correspond to the sides on the other. And then the last one is an application of this. So we're going to calculate the length of AP, and they are giving me a perimeter of 43 centimeters. Again, perimeter is when I'm going to add up all of these sides. So I'm actually given the converse of that isosceles base theorem, which if you go back to this, it said that if two angles of a triangle are congruent, then the opposite sides of these angles are congruent. So flash forward, I'm given that two angles are congruent. What that means is that segment AP is congruent to segment AY. So what I'm going to do then is call I'm going to call each of these segments X. So I know that my perimeter P is 13 plus X plus X. Basically, all I'm doing is adding up all of my three sides. And again, the reason I knew that I could set these equal to each other is because the angles across from them are equal to each other. Now let's substitute some information in. 43 is my perimeter, so I'm going to substitute that in for P. And I'm going to simplify. X plus X is 2X. So now let's do a little algebra. I'm going to subtract 13 on both sides. So I end up with 30 equals 2X. Divide both sides by 2, and X comes out to 15. So what that means at the very end are each of these sides are 15 centimeters. And the problem was just looking for the length of AP. So you would say that AP is 15 centimeters. Okay, so again, it was an application of the isosceles, or the converse isosceles base angles theorem, which there's a lot of information in this video. Go back, pause, rewind, fast forward. I would even go back and maybe watch the proof again before you have to try the proof for the assignment that's associated with this video. So yeah, keep laptop open and give it a go.